Hello and welcome to part 6 of Demystifying Data Science. And in part 5, we looked at data processing and how crucial that piece is to the entire workflow of data science. But in part 6, we're going to dive into our Jupyter Notebook and start really unpacking what that data processing looks like in when we're dealing and manipulating data. We're going to do that with the use of the Pandas package and the Matplotlib package, and also the Seaborn package, which is built on top of Matplotlib. So I just want to briefly cover what we're going to do in Pandas. We're going to import the data. We're going to grasp an understanding of the data and start to clean it. And then in Matplotlib and Seaborn, we're going to visualize and group that data together to really tell the story and unpack, what's behind that minutia of data points. So let's jump over to our Jupyter Notebooks. Now, you can follow along with my Jupyter Notebook here. I have everything written out on my GitHub page. I will post the link to this same notebook in the description of the video. Go and check that out. Code along in the video in your Jupyter Notebooks. Have that GitHub page open. Feel free to access it anytime. Please really utilize that resource. I put some time and work into creating this notebook. Put some time and work into creating this notebook for you, and I think there's some really relevant and good pieces of code that you're just going to be able to use and apply to other areas of your career or whatever kind of data work that you'll be doing in the future. Okay, so EDA, Exploratory Data Analysis, is just, we're going to go through that whole process using the Titanic data set. So we're going to import it from the Seaborn package. We're going to clean it. We're going to visualize that data set. So these first few lines of code here, these are our tools in our toolbox, and we're just getting them out and putting them on our bench. Imagine if you're a car mechanic and you're going to go change a pair of brakes. What you're going to probably want a few tools, your socket set, what have you, whatnot, and make sure you have your brake pads or your rotors or whatever. All this is what we're doing. We're importing all our necessary tools, all of our necessary packages, which is going to allow us to go and actually do the work. So NumPy we talked about, Pandas, Matplotlib, Seaborn are kind of new. Matplotlib and Seaborn are kind of new for us. We're going to talk about in this video. So after the import statement, the name of the packages, like matplotlib.pyplot, and then Seaborn, those are the names of the packages, and we're going to import them as the conventional naming styles. That's PLT for Matplotlib and SNS for Seaborn. Shift-Enter to import and run all those after you've written that out. And it's going to take some time because those are pretty large packages. They're pretty robust, and we're taking the time to rummage through our toolbox and put our tools on our tool bench that we're going to be using here. Next, once that is up and running, Seaborn comes with several preloaded data sets. Really easy to access. Just by that, we're going to name that data set DF, and then that's equal to. This is how you access. This is the actual data set in the Seaborn load data set Titanic. Make sure that's cased in quotes, and then those parentheses out there. All right. So if you're interested in learning how to find data online and pull that in, whatever external data sources you're interested in, and maybe even where to get external data sources and work with external data sources, all of that's available on the web, and it's very easy to pull in. I have another video, I have another series on just the Pandas package, and I talk through how to get and import data into your Jupyter Notebook. So if you're interested in that, check out my series on Pandas and work with Pandas, and I believe it's part 3 where I talk about importing data from online and elsewhere. Enough on that here. We are focused on the Titanic dataset. The Titanic dataset is a very tragic one. It's based on it's a series of data based on the tragic story of the Titanic, the ship that sunk in the sea, and it's based on all the data points are around who survived and who didn't, and maybe what caused that. And we're going to do an exploratory analysis of that here. It's a little bit morbid, but it's a data set that is very popular and widely used, and there's a lot of different resources. A lot of code's been written on this data set. and it's a great one to learn on. When you write that code to import that data set, df.shape. That's when you import a data set, you always want to look at the shape. How many rows, how many columns? Shift enter to run that. We have 891 rows and 15 different columns. That's pretty good. That's not the entire that's not actually the entire full picture of the people on the Titanic. I believe there are around 2,500 passengers altogether. But of the passengers that the data was recorded, we have a pretty significant chunk of these passengers, and we'll start to unpack and unfold all the data points we have. What are those 15 attributes of these almost 900 passengers? So next line of code, df.info parentheses. This is we're going to see the keys. The keys are just another word for column names, and how many values are in each column, and the type of data. So shift enter there, and like I said, all of your column names are out on the left, and those are known as keys. And then your non-null values, how many data points do you have in each column that are not null, and then what type of data is it? Is it an integer? Is it float? Is it a boolean? Boolean's true false. Is it a string? String is just a text value. Think of a text value in Excel. Those can be both numbers and letters, but it's rendered as text. And if you see here, you see dec. That is useless. That is like that's a little more than 20% of the entire data frame we have, so completely useless. We have a pretty much full data set, with the exception of age, but I don't think we need to drop this from our data set, because we have most of the values there, and we can find a way to impute that in a pretty good way. But I think we should drop from our data set this dec. It is completely worthless because of how few instances of data we have. So code to run that is df .drop, and you want to rename the data frame, so your new attribute is going to be df equals df.drop. df stands for data frame. It's how we're going to reference our data frame. It's shorthand. It's very easy to, and it's not all people name it df, but it's mostly it's conventional. It's a conventional naming system for when working with data frames. Some people name it, what the subject matter is, or Titanic. That can be the name of your data frame, but for all intents and purposes here, we'll stick with the fairly conventional naming system. So what this code is doing is we are dropping this column, and we're dropping dec, and we're specifying, yes, axis 1. Remember, axes are 0 for rows and 1 for columns. So you want to drop dec from the column. You completely get rid of dec. And the next code we want to run is head. So our data frame, what's the head of our data frame? And that's going to show us the first 5 rows, of our data set. If you wanted to see the last 5 rows, you could do df.tail, open parentheses, and that's going to show you the last 5 rows. Shift enter to run that. What we get here is the first 5 rows with all of our attribute names. If you remember where dec was, it was between adult male and embark town. If you look down on our head, between adult male and embark town, there is no dec. We dropped it from our data set. It no longer exists. So that is we're already starting to clean. It's the natural process. Once you start to understand your data set, the next step is clean. It's like walking. It's natural. You want to continue down that road and just work with that data, and to get it to a point where you can start to run your visualizations, which then leads to machine learning. And it's a fairly intuitive process that we're following. df.describe. So we've got the info. We talked about info, and that's going to print out kind of a basic understanding, big picture, what our data frame is. Then df.head, we get to see a snapshot of what do those columns actually look like, what do those columns and rows actually look like. And then df.describe, shift enter to run that, and that's going to take all of our numbered, all of our values that are numbers, so all of our booleans and all of our integers and all of our floats, and that is going to take a look and do calculations. We're going to get the mean, we're going to get the standard deviation, we're going to get the minimum value, all the quartiles, and the maximum value, and the count. How many records do we have in each row? Standard deviation, this it's just invaluable, super easy to run. Runs it on all of our numerical columns. Such a very fast and intuitive, excuse me, very fast and intuitive way to get all of our information here. Okay, so moving on. We talked about the age column, and the age column was it wasn't full, but it had enough data where we were still very interested in that column. And an easy way to use the context of the data to fill in those values, to impute some new values, is that interpolate function. And the way we do that is we want to call our data frame, and that's what column we want, and then we're going to make that equal to, we're going to impute values using this Pandas interpolate function. I think I'm saying that right. And then once we impute those values, let's look at that describe again. And what we see here is now we have a full data set. Now age is no longer 714, but it's a full 891, which is how many rows. That's the complete rows. Yeah, it fills it to the end on both sides. And if you want to compare, I really highly recommend, if you're going to impute, do a before and after snapshot. And you want to look at your mean, look at your standard deviation. If they fall in line, if they fall pretty close to one another, that's what we want. If they're way off, if your min and max are way off, then interpolate shouldn't really touch your min or max on either side, because it's using the context of your data to kind of fill in, what the averages are. Our standard deviation did decrease by a little bit, by 0.6, which is that's pretty good in my book. The mean pretty much stayed the same, just like 10% difference, not even, which is not even 10%. That is like 4%, 3%. Wow, yeah, so 3% difference. I mean, pretty good. That interpolate is a really good function, and that's what we want to see. If it was way off, we might go back and change it, because we want to stay as accurate to the facts that we have, the actual data that was recorded. Okay, I have here, now that we understand our data, we want to start visualizing our data. And what I say, I want to start with simple graphs. You want to hone the skill of asking the right questions of your data, and then seek to understand those questions with visualizations. And that's really going to help you craft your narrative, or help you craft the narrative of the data, and not, craft your narrative of the data. That's probably not what you want to do. You want to craft the narrative of what the data is describing and what is inside the data there. Histograms are really easy ways to see the whole distribution of the data. So let's run that. .hist is the way to run that, and we are going to run that on age. So data frame, we want to look at the distribution of the ages in our data set. Shift Enter. Now this is kind of like out of the box Matplotlib. This is what it's going to give us. Probably not something you want on your final presentation, but this is what it's a great analysis tool. And this is a simple line of code. We get the distribution. It's a simple line of code for us to get that basic understanding of our data, and like to do this exploratory analysis and see, what the breakdown is. We want to see our distributions. We want to see things going on inside the data, and get a better visual understanding. A picture's worth 1,000 words, right? So let's bring as much data as we can into pictures, and then start understanding our data on a deeper level. So I have all these grid lines, lots of bins, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different bins. That's a lot of bins to really understand. 2 easy tips for making your graphs more readable: use Seaborn's set style, and and use a background color for your graph, and then change your bins into more manageable chunks so it's more visually pleasing. So we do that here. Shift Enter. We use that set style. Now we have distinct bins. We've binned out into 5 different bins. In the set style, look, we have a darker background, we have a dark grid, and our bins are now brought to the front of that grid line. So SNS set underscore style dark grid, and then we're calling that this is the same. We're looking at the same distribution of the same column, but we're changing the bin size. That's all we did. That's all we did for the first line of code. But we did that with the set style. Now from here on out, all of our graphs are going to be in that set style of Seaborn's package set style. If you want to change it back to the Matplotlib, the default Matplotlib, this is your line of code you want to write. sns.reset underscore original with the open parentheses. That is the line of code to get it back to this. From here on out, everything is going to be in the Seaborn style. So this nice little one you definitely want to stick in your top hat, stick in your back pocket to use for later, because I mean, this is useful. The Matplotlib style is useful. It's the default, but one for presentations and stuff, we'll want that. Also, setting your grids. There's dark grid, dark white, tick marks, whatever that you could all put in this for this argument, and that's right from Seaborn's website. Okay, so pair plots. I want to talk a little bit about pair plots. They're completely useless as far as this, and I'm just going to run this because it takes a long time. While I talk about it, pair plots are completely useless or 99% useless for this data set, but it is something you're going to want to keep in your back pocket for other data sets. It's going to take all of your numeric values and just run, it's going to take all of your values and then run histograms and scatter plots on each and every single value. And what we're doing here is we're doing in the pair plot. It's a Seaborn package. It's from the Seaborn package, and we're doing the analysis on our data frame, and hue is survived. So as I talked about earlier, the data set is based around who survived and who did not survive on the Titanic. So it's going to break our analysis out in the color of based on survived, and survived is 0 is did not survive and 1 is survived. That is in the data set. It's just all the hue is doing is changing the color based on the 0 or the 1 that's already logged in the data set. And you see here, I mean, there are a few useful pieces of information here. The priority class, 0 is did not survive, 1 is survived. Priority class 3, I mean, high levels of fatality for priority class 3, and that's a pretty sad state of affairs, and we can that's one thing with data. You don't want to kind of impute your own motives or your own thinking and let the data speak for itself, and that's why we want to do data. But you see, the truth is revealed in the data. You can see priority class 3 is we can do a little bit more digging and see whether there's a higher number of those people. But regardless, it's sad to look at, especially for this data set. But priority class 1 members had the highest chance of their histogram. It's a kind of a roundabout histogram that they have the highest number of living statistics. Anyway, you have your different scatter plots, and you can pick one of these and dig a little bit deeper into it. This I think is interesting, the fare and the age. So we already looked at our age in data.describe from 0 to 80, and then how much people paid for tickets. We can see here that the top fare is a little over $500 down to 0. Let's dive into that one, I think. Creating scatter plots, and if this link here is to Matplotlib's website, and different color mapping, and it's a lot, talks more about their scatter plots, and it's a good resource for you to get more familiar with Matplotlib. Shift enter to run that, and what we see here, let's just talk through these lines of code first. So we're using the data frame plot.scatter, so we're using the scatter plot. Our x-axis is we're going to use the column age, and the y column is going to be fare, so how much they paid. So what we're doing is replicating. Where was it? Yeah, we're replicating this scatter plot. And what we want to do is the color. We're going to name the color survived. So 1 is going to be yellow, 1 is survived, and then the blue is going to be did not survive. And then the color we're going to use, the contrast here is plasma. There are a number of different colors you can pick from, which I named up here. Those are all the recommended ones by Matplotlib. And if there were, I mean, this is a binary. This is binary data, survived, not survived. If there were gradients, say in another data set, the scatter plot would phase as it got closer to either side. So that's a pretty cool feature and function. Size of the data points is 80, and you can play with that. That's actually pretty big for what we have here. So let's do 50. And so you can see change that size there and make those data points a little bit smaller. Also, the fig size just changed because we ran this. We can see the fig size down here. We want to change that to, we can change that to whatever we want. Make the figure itself larger and smaller, which is pretty useful and helpful. Yeah. So, and this is, once you set these, they're gonna stay true, and they're gonna stay the same for all the rest of the graphs you run. So you can always come up here or change your fig size on any other of your figures that you run throughout your exploratory analysis. One thing that we also want to look at is we want to count the number of people who survived and the people who did not. And so we just take out of the 891 instances of passengers we have, we can see what the distribution of the fatality rate compared to the survival rate was. So we have 550 passengers who did not survive, and then 350 around passengers who did survive from the entire data set. So easy to run count plot from just counting the number of instances on a column, and make sure you use that. Make sure you name the data frame. So we can do the count plot again on the males and females. Shift Enter to run that. SNS count plot. We want to do male or female, and then we're changing the hue to survived, and that gives us that little key here, and then we're calling that our data frame. So survived, and we have that nice little key of males by and large, wow, did not fare well. And then the females, however, their survival rate is much higher compared to the males. And so you can see, if once you start to visualize and understand this, we can see what are the actual statistics. So these are giving us good visual representations. And now, as we this should really spark your curiosity and see, okay, what are the actual statistics and numbers, and how to match those statistics and numbers with those graphs. And that is what we're really going to start to really dive into here as we expand our analysis and really continue to dive deep in that exploratory data analysis. Last graph that I really want to touch on here is the class. We talked about class. So we named, it's another thing you do is name your X and Y labels. So thanks to the Matplotlib package, it's very easy to name. You could type whatever you want here. You could just type, I mean, if I wanted to delete that, Shift Enter. Why did you? Oh, yeah, X label passengers. But put it back to passenger class. I just want to show you how easy it is to name your X and Y labels. You can even put plt.title. And you always want to wrap it in quote. Make sure I was wrapped in quotes and in the parentheses. So passenger class. I'm the worst at spelling. I know that is spelled wrong. And GER. Man, sorry about that. We'll just say pass class. Pass class. There we are. Pass class. Cool. And so you see this distribution, passenger class 3. So from our analysis earlier, when we were talking about the pair plot, with the number of fatalities was much higher in the passenger class 3. That could largely be because they make up such a larger percentage of the entire data set. So just good questions to ask. What's really powering this? All this is just text. What is creating this graph here is just this one line of code, the count plot on the attribute, and then you would just want to name the data set it's coming from. That's helpful if you have multiple data sets within imported into your Jupyter Notebook. But even if you don't have any, even only if you have one, you still need to name that. But you can really see how this is all working together, and we're really gaining that full understanding of our data set. Now, I want to talk about grouping, the last thing on this. I know this has been a fairly long video, but I want to show you kind of the power. We've talked about the visualizing with graphs and how we start to understand our data set. But now grouping is a way to combine insight from across various attributes from our data set, and then we can really dig really deep and combine those grouped attributes with those visualizations and graphs and really extract so much information from our data set. Shift Enter to run this. Group by is if you're familiar with SQL, group by, it's going to work similar to that. The Pandas command group by is just incredible. It's just awesome. You can name multiple attributes. So we're naming the embarked town and their survival rate, and whether they survived or not. So each column is so embarked town, whether or not they survived, and then what was their average fare. So we're aggregating, thanks to NumPy, the mean of the fare, and then this unstack. So let's get rid of. I just want to show you this is this unstack. If we didn't use that, this is how our data set's going to come out. It's a little bit less readable. So that's actually, if we put .stack, this is how it would come out. If you say unstack, this is how it's going to come out. It's going to stack it in a more manageable way. So you can see people who survived. The Cherbourg, I'm not sure. I'm not too familiar with these towns, or Queenstown or Southampton. Oh, Queenstown, they did not fare well at all. Wow, their survival rates, their fare was pretty. Well, we know they didn't fare well because we can dig deeper into this, but what they paid for their tickets on average probably lumped in this class 3, and that's something we wouldn't necessarily want to assume, but it was something we can that kind of stands out, and we can dive deeper into that. But the average fare that was paid for people that survived and people that didn't survive, and based on where they embarked in on. I hope you see kind of how powerful just this one line, information we get from just one line, and how it aggregates and groups and pulls out all of our data together. One more example of group by here is survival rate based on sex. So we saw that the females had a much higher rate of survival based on our graph up here, our count plot. But what did those numbers actually come out to? If you're a female, you had nearly a 75% chance of survival, compared to if you're a male, less than a 20% chance of survival. Just absolutely wild. Easily calculated with the group by statement, combining different attributes and getting the mean, aggregating them. And then another group by here based on class, based on what priority class your ticket was in. So we did see that from what we've seen earlier, that the vast majority of passengers were in the third class. Still, if you're in the third class and female, you still have a higher chance of survival than if you were a male in first class. So pretty interesting stuff here. Just cool, interesting information you can pull from the data. Here's where the real power comes, is when you start to add the group by clauses with the ability to plot and visualize. And Shift Enter for that last one, and we can see the actual survival numbers of males and females in our data set. And so what we're doing is we're getting just by use of the group by, we're summing the numbers of the survived and naming those axes. I hope you learned a lot from this. This has been just a crash course in data exploration. There's so much you can do. There's so much more you can do. I think we're going to end the series in our next part 7, and we're going to do some machine learning on this data set, some classification machine learning on this data set. So I hope you've gotten a lot thus far, and feel free to write in the comment section if you want to learn more, if you feel like you've learned something. I hope you have. Feel free to reach out, and I appreciate you guys watching the video.